Hello, dear authors and invited guests. Welcome to technical session 1A. Good morning, good afternoon, good evening, wherever you are. And it is my great pleasure to welcome you to the 5th World Conference on Smart Trends in Systems, Security and Sustainability through Zoom on behalf of WS4 2021 and Global Knowledge Research Foundation. We are thankful to everyone present on this platform to go along with us digitally for the conference in these unpredictable circumstances of COVID-19 and making this conference more productive. Also, we wish everyone and their families a protected time, and we all together pass this soon. We hope you enjoyed 2 days of the knowledgeable and interactive sessions. Just before we get started, I would like to introduce you all to the chair for this session. It is Mr. Ebrizal Abdul Qadir. He obtained his PhD in wireless communications from the University Technology in Malaysia in 2014 and a master's in engineering in electrical electronics and telecommunications in Malaysia as well in 2008, while his bachelor's in engineering in electrical engineering it was at Bung Hatta University in Indonesia in 1998. He continued his research as a postdoctoral fellowship at Big Data Center Faculty of Computing from 2014 to 2015. He has been working on several companies that provide system solution in telecommunication and radio frequency identification in Malaysia, Singapore, and Indonesia. He joined Islamic University of Riau in Indonesia as a lecturer department of informatics engineering since 2015 to continue his research related to the wireless and mobile communication sensing system, RFID, RF and microwave antenna computer and networking, WSN and IoT. In 2019, he was promoted as associate professor in informatics engineering, Faculty of Engineering, Islamic University of Riau, Indonesia. Thank you, sir, for chairing the session. Now I would like to start with the papers. Also, there's a special note for the presenters. You will be given 12 minutes for the presentations. On 10 minutes, I will raise a gentle reminder, and I request while the presentation is going on, other participants kindly be muted.
Yes, thank you, Nahid. Can you please
thank you.
In the slide?
So am I sharing it?
Yes.
Yeah. So that will be the session chair for today, and this will be our first presenter.
Hello, everyone. So I'm ready. Okay, so I assume that I will start. Let's see. Okay. Hope that you are looking to my presentation. So my name is Vinh from Industrial University of Ho Chi Minh City in Vietnam, and today I will present our paper with the title of Studying the Fuzzy Clustering Algorithm for the Intrusion Detection Problem on the attack to the DNS. Yeah, so let's go. Well, I mean, I would assume that today, I mean, everyone are aware of the opportunity and the threats that the internet brings to us. In this cybersecurity is indeed a very important research field in both academia and industry. And in the cybersecurity, I mean, we in recent years we focus on intrusion detection system. On the slide, you can see the role and the position of the IDS, intrusion detection system, inside a computer system. It's usually deployed behind the firewall. So basically, the IDS, the role of the IDS is to analyze and stop any malicious traffic from the internet to the computer system. So we would like to note that the IDS do not deal with the internal attack. For instance, if the attack is started inside a LAN. It's not the problem of the IDS. The IDS mostly deal with the external attack, basically the attack from the internet. That's all about the IDS. So the idea of the IDS is placed as a kind of classifier. So when the traffic comes from the internet, it will go through the router and the firewall, and the IDS will classify if the traffic is malicious or benign. So the IDS will have to decide if it will let the packets go through or stop them. Definitely, I mean the IDS have attracted a lot of research in I think last 2 or 3 decades. If I believe that many of you here recall the very famous datasets on NSLKDD 1999, come from the competition in 1999. One of the most popular intrusion datasets that have been used in the academia. However, most of the research study in IDS only focusing on attack to normal computer system. So in this study, what do we do? What do we do is we focus on the attack to DNS or domain name system or domain name server. The role of the DNS, probably we are all familiar with. DNS is as kind of backbone for the internet today. If the DNS stop working, we cannot translate the URL into the IP address anymore. Right? So in this study, we focusing on attack and defense to the DNS system rather than a normal computer system. So let's focus on related work. Again, I encourage you to read my paper for more detailed related work. But in this only one slide, we try to cover several most important state-of-the-art study in the intrusion detection system. And I would like to focus that most of the study here, as I said before, only focusing on IDS for the normal computer system. So as I said, the IDS basically is a classifier, right? So when the packet comes in from the internet, it has to decide if the packet is malicious or benign. So it's very kind of natural or straightforward to apply some kind of classification technique to to empower the IDS. But in fact, the most common IDS that have been used until now, even in the industry, is a rule-based IDS. So basically, the experts, just like an antivirus program, the expert in the field have to decide, have to define some rules, such as if the IP address is in this list, the package is kind of malicious, because it's very fast, right? And we can debug and understand the problem. And definitely, due to the rapid development of machine learning, more and more research study for switch to using machine learning technique for IDS. I would like to name a few here. We have some research study back in early 2000s, including some work using the technique that are popular at this time, including logistic regression, SVM, decision tree, and after that, around 2010, we have other research study that try to use a random forest, and recently people start to use different boosting machine, including GBM or EasyBoost or CashBoost to empower the classification performance of the IDS. And definitely, I mean, because we are living in the era of in the era of deep learning. Also, there's a lot of study that try to use deep neural network, including convolutional neural net or recurrent neural net with LSTM to classify either a package is malicious or benign. The problem is because usually the intrusion data is quite well formulated. Usually we have like a tabular data. So the deep neural network, I mean, doesn't bring a lot of improvement in terms of predictive power compared to, let's say, boosting machine. And according to our paper published from 2019 to 2021, so this year, the boosting machine is so far is the best algorithm in terms of supervised learning to classify the attack to the normal computer system. However, the problem with supervised learning that we already knew for a while, that supervised learning usually require a huge label data set, right? I mean, for instance, one of the very famous data sets in recent years is CIC IDS 2018. 2017, 2018 is it has a total size of from depend on the version, but from the 50 gigabyte to around 100 gigabyte. So you have to collect around, let's say, 100 gigabyte of data. You have to label them. You have to make sure that what the attack and what are the benign. So it's a very expensive task and not easy thing to do. We have another technique such as reinforcement learning. With the reinforcement learning, for instance, we have another paper published this year using reinforcement learning to classify. So with the reinforcement learning, we don't really need kind of the label data set because we can let the IDS to interact with the system, and after that we can observe the response of the system, and we can improve or update our reinforcement learning model. So it's resolved a very major concern of the supervised learning. But the reinforcement learning have another problem that you have to let some attack or some kind of malicious traffic go through. So after that, you can observe the response of the system, right? And maybe it will be too late to do something like that, just like kind of antivirus program, but sometimes you have to let some virus go inside the computer, and you can update your model, and probably maybe it will be very late, right? So there's another task called unsupervised learning, and the most popular thing, the most famous unsupervised algorithm probably is K-mean, that we cluster the data into cluster or into group, and after that, I mean, we can let's say classify them based on the clustering. So in this study,
apologies, Quang, you only have a few minutes. You only have a minute left for your presentation.
Yeah. Okay. Sorry. So we instead of hard clustering, we K-mean, we use the soft clustering. So basically, a data point can belong to multiple groups rather than just one group. You can read the detailed algorithm in the paper. So we use the dataset WS4. Basically, is the dataset attached to the DNS over HTTPS. The dataset is released in 2020, so very recent dataset. So this is quite kind of modern dataset. So I compare my algorithm, the fuzzy clustering to other algorithm, and as I said, the EasyBoost is so far the best algorithm in intrusion detection, and it achieves the accuracy of almost perfect on almost 100%. However, the fuzzy clustering can be comparable to kind of weak classifier like naive bias algorithm, for instance, with the performance is a little bit higher, not significant. And compared to K-mean, K-mean is quite bad in terms of predicting the model attack, right? You see the accuracy is only 52%. So it's almost kind of random guess. So our conclusion is fuzzy clustering set a different light to the IDS problem because you don't really have the label data set. So it saves a lot of money and effort, but you can achieve quite good predictive performance compared to, it's not comparable to kind of XGBoost, but you can compete, it can compete with, I mean, kind of weak algorithm like decision tree or knife bias. So fuzzy clustering is somehow underestimated in academia. So we believe that it has a lot of potential to use not only in academia but also in industry. And this also concludes our presentation today. Many thanks for your attention.
Thank you, Quang Vinh Dang. And if Evzal or if any of the participants have any questions, please can you message the presenter directly, and hopefully we'll be able to answer your questions. So just to share my screen.
Yeah, I will stop sharing.
Yeah, thank you.
Thank you, Nahid, for the times. Okay, all right. Finn, you've risen on IDS using fuzzy, studying fuzzy. I saw your result. You got 4 results comparisons. There is a fuzzy XBOS. Is it you test or you conduct experiment with the same case or same scenario among the 4 algorithms?
Yeah, sure. We follow kind of standard in industry today, divide with train validation and test sets, and only validate the 4 algorithms using the same test sets. So the results are comparable, I believe. Yeah, hope that it answers your questions.
So, yes, you got the XBOS, the good one, the almost 100% scenario. Is it just now you got? Sorry, you already stopped the scenario. It's okay. During the vote, which one is the? Is there any other algorithm you compare to other, like now is something like deep learning or something like neural network?
I don't display everything here because I think there is some kind of representative. Sure, but I mean, in my paper you can find also the more detailed result and also the reference to my other paper that we compare. I mean, several other algorithms such as deep neural network or random forest. But I mean, if you look to the result, the XGBoost is already almost perfect. So if we say if we compare in terms of classification, probably XGBoost is already do all the job, and I mean there's very little room for any kind of improvement, I would say. So we have to, I mean, I think we should look to other criteria such as the computational power or processing time or other things. But if we look only to predictive performance, such as accuracy, AUC, F1 score, I mean, probably there's a very little room to improve.
Yes,
I hope that it answers the question.
Yes, thank you. I think in the instruction detection system, we have to compare many parameters. Maybe it's not just now you detect for the DNS domain system, maybe because the internet, the transaction is epic to many parameters. We have to in terms of the type of data, everything. I have experience to detect the abnormality on the internet access, spacious, malicious. In the internet access, there is even the time, type of the user behavior, everything. So thank you. Anyhow, thank you for the presentation. So
yeah, many thanks. I will look to that. Many thanks. Yeah.
Yes,
right.
thank you, Vindang. Thank you, Avizal. So if anyone has any query with Vindang, you can put the question into the chat box. So he will answer into that. And we move ahead with our next presentation. So our next presenter will be Osama Omar from Egypt, and he will present a paper on robust facial based interbeat interval estimation through spectral signature tracking and periodic filtering. Uh, so yes, Osama, I have made you co-host. Please say your presentation.
Yeah, thank you. I can make share for my presentation. Okay.
Yes.
Hello, everybody. I am Osama Omar from Aswan University. I will present our paper, robust facial based interval estimation through spectral signature tracking and predict filtering. Here is the outlines of my presentation. First, I will show the objective of our paper and the outcome, and then the proposed BBG monitoring system and BBG estimation method and ROI selection methods, and then the challenge and how to cope with this challenge, and then the results. Firstly, our objective of our paper is to estimate BBG for to be suitable for ICU as well as lab videos. The main outcome is the full remote BBG estimation system that can be used for heart rate for many applications actually, including heart rate and blood pressure and SpO2 and many applications for BBG using BBG estimate. As conventionally, the BBG estimation is going through many processing, including that is facial based, including face detection, tracking, ROI definition, and then extraction for the raw signals, and then signal processing stage, which include the trending and normalization and smoothing and filtering and applied signal separation. So actually, here is we focus on how to reduce the signal processing step or stage by replacing the turning, normalization, smoothing, and filtering and blind signal separation by to be replaced by two-stage filtering or predict filtering. And then the BBG estimation, the final stage. Here is the main block diagram of our monitoring system, including or starting from input videos, and then go through phase detection and tracking and ROI. Here, actually, we tested many ROI selection, including phase part and the skin part of face and part of face selected certain part, including the checks and forehead. And then the raw signal estimate extracted from the region of interest selected, and by analyzing the spectrum of these raw data, we add or process this signal using the adaptive filter or adaptive, actually selective filter or a periodic selective filter, and estimate the fundamental frequency and the first two harmonics to include or estimate the blood BBG or photoplethysmography signal. Here is one example for the stage. So this is for my own videos. This is at first we start with detection, which is cropped by the red box. And then we estimate or select the region of interest, including the skin regions and part of face, which is select or cropped by the yellow block. And the last block is the skin only or skin region. The BBG estimation, actually, as I mentioned in the block diagram, is a traditional processing usually involves long processing chain, including smoothing, the trending, band pass filtering, and blind signal separation, which include BCA or ICA, which takes a long time, and sometimes actually the processing is not so accurate. So our proposal is to replace it by simple two-stage periodic filtering. The main idea resides here is exploiting the fact of spectral concentration or the fundamental and first harmonics component in the PPG or in the extracted raw data, and doing the filtering for in band of 0 to 0.5 to 5 hertz, and then we can estimate or select the fundamental and the harmonic or two first harmonic frequencies to estimate the PPG signal. Here is an example for the multi-band filtering, and which can show the spectrum of the PPG signal spectrum and the filter or the bands which can be selected around the fundamental and the first harmonic frequency. Here is another example. Here is for the first example actually for the contact-based PPG, which is signal recorded by contact PPG sensor, and here is the signal which is extracted, or the raw data extracted from the facial information, including the red and green and blue signals. So this is the raw for the three channels, and here is the CPP or the corresponding contact-based PPG spectrum. So it can be shown the correlation between the contact-based PPG or the CPP and the remote or facial information from the red and green and blue. So our task here, or our goal here, is to add the filtering or design filtering multi-band filter around the first harmonic to be selected the fundamental frequency and the first and second harmonic frequencies. Here is an example for the real data. Actually, it can be shown here. There are multi high peak for the spectrum in the for the fundamental, which can be thought as illusion for the fundamental frequency, which can be not clear here for this real data. Using two-band filtering, two-band filtering, here we can get the fundamental frequency, which can correspond to one application, which is correspond to heart rate, which by testing the corresponding ground truth heart rate, we can show there is some error for red and green signals. Around 2 here for case in red signal, error equal +2, or in case of green, error equal to +2. This is for the application of heart rate, which corresponding to the fundamental frequency. This is actually to inform or to check the accuracy of the fundamental frequency estimation from the remote PPG signal. Here is some examples for different videos, including heart rate for phase green or phase red, or red signal for phase, or green signal for phase, errors around or related from -4 to +2 or +4 for a case of red phase. There are some challenges actually for PPG estimation remotely, including the challenge in camera, which including the resolution for the cameras. So we try to use different resolution or different video resolution for using different frame resolution, spatial and temporal resolution. Also, there are some challenge regarding the light sources. So we try to fix the light source using LED light source. This is actually in lab videos. There are some challenges including or regarding the skin. So there are some challenge for the black skins. So actually, we try to solve this problem by trying to enhance the resolution for the videos, including black skins, and trying in another direction using more photons or more light sources to increase the reflected lights or reflected signal from the black skin. There are some challenges regarding the region of interest. So for that, we treated with different region of interest, including face and parts and skin signals, skin faces. Sorry. This is actually the challenge and how to we treated with this challenge, and there are some still ongoing modification or enhancement for the proposed algorithm for BBG estimation to be accurate, to be used in case of ICU and as well as lab videos. Okay, this is the end of my presentation. Thank you.
Yes. Hello.
Yeah. Okay.
Yeah. Thank you. I mean, sorry, I just direct to asking a question. So thank you, Prof. Osama, for the presentation about the image. You use image to detect some behavior. So as your slide show just now is challenge on the image, on the likes, on the distance, on the behaviors. Do you doing data trainings or something? I mean, you get collect some sample of image, then you analyze a few sample of image, something like kind of.
Yeah, actually, yeah. Okay. Please. Okay. Complete. Okay.
Yeah. Continue.
Okay. Regarding to the training, actually, we make training for the detection and tracking stage. So our detection and tracking algorithm is based on deep learning, so it's include training. So I assume that the training, detection and tracking is already well known, so I just go ahead for this passing through this stage directly. So I just mentioned we use detection and tracking. Even we use many detection and tracking algorithms, but actually our results include the deep learning based detection and tracking.
Okay, yeah, yes, because I saw your challenge. Yeah, some people they are doing that because they are the image, our face, yes, different time, many affected from even the quality or the resolution of the camera and everything. Normally we doing is collect all data, then we redo and we do data training and skip the data. I think they can one of solution we can do. Okay, I think that's all. My from my Mr. Josie, my question. That's all.
Thanks a lot, Dr. Avisal. So now, if anyone has any question with Dr. Osama, please write into the chat box. He will answer into the chat. And we move ahead with our next presentation. So next presentation will be given by Robin from Germany. He is going to present a paper on green mile gamification, supported mobile and multimodal route planning for a sustainable choice of transport. Yes, Robin, you can share your screen.
Wonderful. Thank you very much. I'm quickly going to share my screen. I hope you can understand me well. So you should see my screen now. Yeah. Okay, so I'll start. So welcome to my talk about green mile gamification supported mobile and multimodal route planning for sustainable choice of transport. So something completely different than before. Well, sustainability is usually mentioned in connection with climate and environmental protection and indicates that products and projects should aim to protect our environment. And sustainable development should satisfy present needs without compromising the conditions of future generations, and resources should be used without overusing them. And in such efforts, the societal transitioning from utilizing transportation with a high CO2 emission, for example, by a car or plane, towards a public transportation, for example, bus or train, is seen as an important objective. And often such efforts rely on technical innovations, such as novel engine technologies or stuff. However, sustainability within the transport sector can also be adjusted by people's decisions regarding their choice of transportation. So people using less CO2 emissive transportation could reduce the overall emission, of course. However, different aspects can influence such decisions, for example, costs, convenience, and the travel duration. And it's very common to use mobile apps as part of our everyday life to plan such journeys. So what was the goal of this work? The goal was to investigate in how an app can help users in making informed decisions about which routes could be used for the journey, considering the sustainability of the utilized transportation vehicles. So what did we do? We investigated in different game elements within a mobile app we call Green Mile, which is a gamified, multimodal, and mobile route planner app that helps its users to make informed decisions on how certain routes and the transportation they incorporate impact actually CO2 emissions. So in particular, we focus in this work on aspects about, on game aspects about onboarding, narrative, leaderboards, levels, and achievements. And this graphic illustrates our onboarding within the app. It is conducted by providing 4 simplistic screens. The first time Green Mile is started on a device, the first screen here on the left describes that Green Mile is a multimodal route planner, and the second screen on the right introduces collaborative and competitive leaderboards that we describe later. Then the third screen of the onboarding introduced the user to a simple narrative we designed for Green Mile. The user is assigned to take care of a plant avatar. It grows and flourishes during the usage of Green Mile. The more CO2 emission was avoided by the user, actually. So this is the narrative in this gamified app. The narrative is utilized to engage the user and give the sustainable decisions a very direct meaning within the app. And the avatar represents this meaningfulness visually. And finally, the last screen of the onboarding here on the right provides a motivational message about that sustainable daily travels can actually have a direct environmental impact to engage more of the philanthropist player types that exist. And after the app's onboarding, users can access functionalities to fulfill the main purpose of a multimodal route planner, which is planning routes from start to one over several target destinations. Besides common functionalities illustrated on the left, we provide educative elements within the planning process. We provide different route alternatives for a query. Particularly, we provide users with the fastest, the cheapest, and the route with the least CO2 emission to select from, which you see here on the left. And when a specific route was chosen during the process and the destination was reached, a suitable narrative notice is displayed for the users here on the right. For example, if the most sustainable route was chosen, then the user is informed about how much gram or kilogram CO2 he or she actually saved compared to the other 2 routes, so to the cheapest or fastest route. Otherwise, it is displayed how many trees could be planted to compensate the CO2 overhead. So when the user would choose the fastest or the cheapest route instead of the most economic route. And this information is also embedded in the narrative by displaying the impact on the player's plant avatar on the right. For example, if the user chose the most sustainable route, we can think of it like the plant is watered. And if he or she chose another route, the plant, let's say, it dries out a bit to visualize this process. And additionally to sideline gamification methods such as onboarding and the narrative, we considered more explicit gamification apart from the original intention of a route plan app. First, we consider leaderboards a suitable game element in this process. Leaderboards are divided into 2 categories, which are individual group boards, individual leaderboards and group-based boards. So you can also form groups with your friends. And both consist of two parts, the list itself and also the user's avatar. So here also the narrative is included. And the list displays the saved CO2 emission in total in bars and gives a matching value. And for the sake of shortening the presentation, we will skip over this a bit. So then the second game element we considered for Green Mile is using levels. Levels could be graphically represented as a path in this process that the user follows and progress by completing either specific tasks or quests or gathering points as described for the leaderboards. For example, a first quest here might be, let's say, start your first sustainable journey, which is relatively easy to complete. And once the level is completed, access to the next more difficult task is released. And this process can increase the curiosity and the desire to achieve goals or conquer something. It can, for example, trigger the strive for competence and mastery of a game as one important motivator of gamification. However, the user can also be deterred since let's say individual quests might get too difficult for some users. An example would be maybe a business related frequent flyer who might consider the task use the sustainable route 10 times in a row quite difficult since he has to fly. The last element we consider in this paper is using achievements. Compared to levels, users do not have to follow any sequence when using achievements. As soon as a certain task is completed, an achievement, in particular its relating badge, is earned. And in addition, the user's progress is recorded for each task, which can be used as a guideline for the user to provide long-term motivation. A level up mechanic can also be used so that badges can be earned multiple times to level up these badges. And achievements can also offer a social component, for example, by forming opinions through the deeds of others or through comparison with others. And finally, we also implemented Green Mile as a prototype for iOS, and we used it in a user study. So we did a short user study, and in this user study, we evaluated our sustainable and gamified route planner concepts, and it involved 15 participants. We provided our participants with the Green Mile app and then introduced them to 4 tasks they had to solve with the app within a given scenario to ensure they actually had used all features of it. And after completing the task, we asked our participants to fill out a questionnaire. In addition to custom questions, we asked them about the gamification and the relation to a sustainable transportation choice. The abbreviated version of the standardized attractive questionnaire after Hassenthal et al. Was used to draw conclusions about established software evaluation criteria, such as, for example, hedonic or pragmatic qualities, for example, usability. And finally, also 5 participants agreed to undergo an extended long-term study and used Green Mile for at least 3 days, but up to 1 week. And we analyzed the outcome of the attractive questionnaire using its portfolio presentation shown here. It shows that the tool was assessed with slightly higher pragmatic than hedonic qualities. The confidence rectangle here shown in light blue indicates that the confidence of the pragmatic value was also higher than the hedonic ones. And the descriptive statistic of the attractive results places Green Mile within the lower left corner of the desired area. This indicates that our participants assessed the usability of our tool as balanced and usable, actually. However, both qualities could be further improved as well. And further data from the attractive single items and the qualitative analysis support that specifically the clarity of our application's UI should be improved, for example, by making it less complex and more intuitive. And here we see the value distributions of the 6 custom questions that were asked, where low values mean positive ratings. The box whisker plots show that all mean values lie below 4, which is the neutral value of the scale, except for questions Q1, Q3, and Q6 for the long-term group. This shows that the regular group tended towards much better ratings than the long-term group, actually. And in particular, the differences of Q1, 3, and 6 between these groups show that the consideration of collaborative gamification aspects might be actually less effective after initial usage. However, still, interestingly, Q4 was answered more positively actually by the long-term group than the regular one. This indicates that Green Mile could also motivate our participants initially in making more informed decisions, but also has the potential to make a longer lasting impact on the overall decision process by educating the users during the route planning process. And overall, we derive the recommendation that gamification within mobile route planning apps can help motivating users initially to engage with sustainability aspects, particularly cooperative gamification aspects within individual groups. However, the proposed game elements were only partially suitable in terms of long-term motivation. And in our case, it might be valuable considering the game elements also as a kind of an onboarding approach for users, or including these elements just from time to time instead of making them a main aspect of a route plan app. And so we come to an end for the presentation. I thank you very much. We can have some questions now.
Yes, thank you, Robin. I have one question.
Mhm.
So the group, how many support? How many to support in a group, and is it how the accuracy? Did you test several event or times on the accuracy? This your mobile apps gamifications?
You mean in the user study?
Yes.
No, we did not actually. It was like a pilot study with 15 participants. But what we actually will do in the future is we will like build on this concept and build a novel app, and we will conduct a larger study where we also will include things like significance, statistical significance, because I think with the 15 participants, it's hard to conduct a statistics on it. So it was more like focused on the qualitative results, but also getting some quantitative to support the claims.
All right. Thank you. Hope your game can use by public soon. Thank you.
I hope so. I hope so. Yes.
Thank you.
Thank you.
Yes. Thank you, Robin, for the wonderful presentation.
Thank you.
A nice idea. Thank you. So yes, Nahid.
So thank you. And if anyone has any further questions, please use the chat function. So the next presenter we're going to be presenting is Tajim Mahmood Niamat Ullah Akund from the Bangladesh University of Business and Technology in Bangladesh. His paper title is IoT-based low-cost automated irrigation system for smart farming. So if you'd like to start sharing your screen, Tajim, if you're ready.
Yes. Can you hear me?
Yes, we can.
Okay. So I think my screen is visible.
Yes.
Yes, it's visible. Yes.
So my paper ID is 51, IT-based low-cost automated irrigation system for smart farming. And here is the authors list. And in this research, we present a low-cost intelligent irrigation system for farming. Nowadays, farming is shifted to automated and remote monitoring management systems integrated with cloud, fog, and IoT networks. Our developed prototype can measure water level, temperature, and humidity with a hardware sensor and microcontroller unit. We use different sensors to take different readings and values to decide to turn on and off the motor and take decisions. We provide essential algorithms, flowcharts to explain the system. Our IoT application-based automated development system makes an automated system for irrigation and provide notification via mobile SMS also. And the objective is to collecting data of several sensors from the field and giving notification to farmers via mobile SMS and other types, and making intelligent decision and controlling the irrigation system based on the collected data. So our algorithm is shown in this flowchart, which one is very simple. And as we want to make a very low cost design for our farmers of Bangladesh, that's why we make the system more simpler, like it will at first power on and collect the sensors data, then it will show the data to a LCD monitor, and it will control the motors by following the sensor data through a relay module. And if our threshold value is sensor value is less than threshold value, then the motor will be on, and other times the motor will be off. And the notifications will be sent via mobile SMS to farmers mobile. And this is the simplified unit system model, where we have used microcontroller, Arduino, and several sensors like water level sensor, DHT11 sensor for temperature and humidity sensing. And we have also used SIM module, SIM 800L, to send the data to the farmers mobile phone. And we have used a LCD monitor to show the data to farmers, to show the data, collected data, and the motor condition, which one is on or off. And we have also used a relay module to control higher voltage motor with our low voltage microcontroller. And we have obtained a number of features, like a system can automatically start and off the motor with the value of sensor, and system can measure moisture, water level, temperature, and humidity. It can show the measured data on LCD. The system can send mobile SMS notification about all state, which one is when the motor is on, when the motor is off, and what is the level of water, what is the level of temperature, and what is the level of our humidity. And this one is the prototype, which one we have designed. We will set up a final big motor here, and as this is a prototype, we have used a small motor and relay module. Here is the microcontroller, and the other things are shown here. And this one is a sensor of water level sensor, and the SMS module is attached here. And in my mobile, I can see the SMS like this, and the SMS will show the current temperature, current humidity, and water level, and the state of motor, which one is on or off. It will monitor and send the data to us. And I also make a working video of our prototype, which one is shown here. So this one is the prototype. I am testing it with this sensor, and the data are showing here what is the temperature and what is the water level. And when I am putting it in water, then it is showing that the motor is off, and what is the level of water, it is also showing. And when I put it off from water, then it will show that the motor is on, and here it is, you can say see the motor is on, and what is the water level is 0 now when I put it back. And also here is the sensor, and the SIM module is situated here, and the DHT sensor which can collect the temperature and humidity data from field, which one is stated there. And we have used a small motor here. In next, we can use high voltage motors also, and with the help of this relay module, we can control the high voltage motor. And if okay, I think the prototype is shown. And if I check our success rate, we have tested it in several times. several times. From there, we got 85% time the SMS notification is successfully sent to farmers mobile, and when we are reading the humidity reading, it shows 95% accurate data, and when we are measuring the temperature, it also showed 95% accuracy. And the water level, when the water level is below the threshold value, the motor will be on. These features has shown as 99% success. We have tested around 1000 times and we got this type of success rate. And we can also say there are several systems available in marketplace, but they are very high cost that cannot be used in fields of Bangladesh. That's why we made this design, and which one is only cost of $20, like, and farmers can use these things. And also there are several types of features which one is present here, is not presented in the available devices in market. And there are also some limitations in our work, like this proposed IoT system was not tested in very effectively for a long time in a field, or when the monsoon comes or rainy season comes, have a difficulty, because all the things are maybe we need to make some cover up on our sensor unit, because sorry, in our microcontrolling unit, because microcontrolling units will be damaged if water poured into it. And in our future work, we want to make a artificial intelligence system with this, where the system will decide and make some prediction about our field and about our crops, how is the level now and how we can improve. It will make some artificial intelligence decision or machine learning decision in future. We are working on that. So thank you. That's my short presentation.
Yes, thank you for the presentations. Nahid, I just go through. All right. You design IoT for the just straightforward. What kind of parameter will trigger your motors is on off? Is it temperature, humidity, or water level? All those parameter with triggers.
All those features. We have selected a threshold value of water, humidity, and temperature. If the value is less than the threshold value, then the motor will be turned on, and it will send a SMS to farmer automatically, where is her motor is on or off, or the temperature and humidity, what are the exact value now, real time value.
Right. Just did you face any problem on the field? Did you test on the field, on the farming side, this system?
Yes, for several times, but not very long time. We have tested for around 100 times in field.
Yes, because normally the environment in the lab very different to the field, because the field got noise. Like let's say we do in the lab is temperature, room temperature is 25 in the tropical, but in the field sometimes there is noise, like night time, daytime. Sometimes our sensing blocked by obstacles, dust, something like. Did you face any problem, any issue in the testing on the sites?
Yes, we have faced some problem, like in monsoon time or in rainy season. We need to make a cover up of our microcontrolling unit, because if water touches the microcontroller, then it will be damaged. And we also need electricity in the field also, and also we need some battery powers to control our unit.
All right, just you, because the actual environment, like water level sensors, sometimes our drains blocked by obstacles, so they're blocked. Actually, the water is low level, but the block is a high level. So different kind of parameter will send to our system. Actually, it's okay. Thank you. Hope you continue your research and your product prototyping. Thank you, Nahid, for the time.
Thank you very
Thank
much.
you for your, thank you, Tajin, for your presentation and obviously answers to Evizal's questions. If anyone else does have any more questions, please use the chat function for that. So I'm just going to share my screen so we can get move on to our next presenter. So our next presenter is Dr. Bernhard Heiden from the University of Applied Sciences in Austria. His paper title is Human Robot Intermittency and Invariance. So over to you, Bernhard, whenever you're ready.
Hello, yes, I'm ready. Thank you very much for the introduction. So I will share the screen now. And so this is it's not so easy with the full screen. So thank you very much for the introduction. So this is our presentation of human-robot intermittency and invariance. My name is Professor Bernhard Heiden, and I'm from Carinthia University of Applied Science. And with me is today also Bianco Tonino Heiden and Volodymyr Alekseev. And so give a short overview about our presentation. The presentation is the content introduction about beauty, the robot O. This is a kind of orgidone, or it's also with the Holon theory, some kind of cybernetic unit. And then we give a summary, conclusion, and output. And so, first of all, we are all affected by the Sustainable Development Goals. And so, what can be said from our perspective is that all life is affected by system theory, and now we have further developed some parts of system theory that contain all parts of life. Especially, we look at robots and humans. And so, this is the goal of this paper is to present mainly three things: robot-human interaction, how it is qualitatively with from the point of systems theory, and that means what is in general valid. And so this means also the invariance. It means it should be valid very widely. And the second is the description of the robot O. This is a self-organizational cybernetic unit, and I have also brought with me a diagram. And so you can try to use then this qualitative theory also. And you can also, I give also some ideas how to make quantitative measures with computers and so on. And then we give also a short logistic application. And so first of all, let me show this picture from Leonardo da Vinci. And so this shows very well what is beauty. And so this has been tried since 2000 years to measure beauty. But the measure up to date is now what is called aesthetics. And it's very difficult to describe with the computer. But it was also in the ancient times discovered that this could be the golden mean, for example. And in just recently in the last decades has been discovered that this is quite important because these are measurements of the chaos theoretical investigations. And so first of all, let me show some invariants, then the order steps in the logistic applications. And so you can formulate the theory in form of axioms. So this theory is not complete, it's open, but you can build it up from sentences, and this we call also axioms. And so one important axiom that is for the robot humano applicable means that the system, when the system is chaotic or has a strange attractive, it has the greatest potential to build dynamic order. And so this is very important for life, because life wants to build a dynamic order to build some far from equilibrium thermodynamics order. The second is humans and humanos. That means these orgidones, this called from the orgidone theory O's, and robots are getting an increasing similarity. That means human-robot equity level is increasing. Up to now, it's not very fast, so to speak, but sometime it becomes nearer and nearer. In fact, robot development is more than 100 years old. And so they may be also merged with intermittently enhanced properties. And this is a very similar development like computers. And we have seen the development of computers since 70 years. And up to now, it's always changing. And so this is very important. And so the computing ability is also the limiting factor of growth. We all know the Moore's law, and so this is now the case. But in the future, there will be more a material case, and that means humanoids or robots of the future are limiting the case. That means when we have material processes, they will be much more important than ever now. And so, and here comes in the fourth axiom, that means beauty is the next level which comes to be important also in terms of robotics. And so this is related to a species. So I can't go too far into the details, but beauty is always related to a species, as we heard today in the keynote lectures from the tigers. And so the tiger is a species. And so the species is also related to survivability and to sustainability, but also of the whole ecosystem. And the fifth is information content versus true content. We all know that it's very important to have the truth, the facts, and so on. And so the false facts become increasingly deteriorating. That means that it is very important to have security, for example, to get the truth content. That means the truth content changes with the level of category. That means we need higher and better and more truth categories. That means we need theories that are more general. We need techniques that are more general, computers, robots, humans. And the sixth is that a person who is to have a sustainable optimal operation means that you have to cross the potential against the creative potential. That means creativity becomes more important in the future for humans and for robots. And so I've built this up in the stair from the robots. These are the robots from the beginning, from the robots up to the humans, but you can also explain it from the humans. Humans are also using hands for millions of years, for example, and this is what makes up human and his development. And so this is the creativity border. This is the latest border, and we are not really there yet, but this will be the next border for robots. And so this is the idea. We have to create robots that are as creative as humans. As we heard about Industry 4.0, humans are the missing link to machines. And maybe in future, this also will be overcome, and machines will become more similar to humans then. And so then will be regarded like a species. So now two applications. First is the creativity region. This means high intermittency between humans and robots. For example, when we have the elder care, we have to interact with robots, and this means when we interact with robots that these people and robots are very important for us, for example, social robots. And so to make a measurement, a quantitative, that means the irrationality is very important in quantitative investigation, and it has only lately in the last decades been found that the most important numbers are irrational numbers, and so 100 years ago all thought it's so important to be rational, and so this is on the border of chaos, and this is also what was seen in the Da Vinci picture. And this is to investigate this with new mathematical insights. So an application of future logistics. So we have, for example, huge amount of data, decision-making processes, and we can relate this all to these 6 axioms. So that means we need increasing robotic applications, and this is actually the case in Amazon. They have built a factory with 100,000 robots only to use in Amazon, and so nobody knows really how to nowadays. But those companies, those global companies, use this hugely. And so the actual processes can't be foreseen because of the human factors. And so therefore we need also more interactions. And so the humano triangle, the human, the operator, the machine, and the product, they are always interconnected in a constant interactions. And that means this is very important for the future. So summary and conclusion. So I've given a very short introduction, what is future and how we can use this in future human-robot comparability and in computing and robot applications. I've given 6 axioms of robotos and said what is a roboto, an informational unit, including a robot or a human. And then we have the gap between humans and robots that is becoming smaller. That means we see this, that human suffering is in overall decreasing. And we have an order hierarchy of robots. And we have seen these steps, and we see that we are becoming closer and closer to each other from the species standpoint. What is the outlook? The outlook is that the human-robot intermittency increases both human and robot survivability, and this will be and is already a co-evolution. Thank you very much for your attention.
Thank you, Berhad. I have one question. So
Yes.
now the evolution of the robots, many companies developing the robots. So based on your opinions, how is current status of the intelligence of robot to the human's intelligence? Let's say, is it 100% or 90%, 80%? So is it one day the robot intelligence overlap human intelligence? How is your opinion?
Yeah.
Thank you.
Thank you very much for your question. This is a very intelligent or a very different question. I think you have to discriminate between humans and robots, and humans are never like robots somehow, and robots are never like humans. Also, they are coming nearer to each other because they have other origins. And so robots are made from humans, and they have some capabilities. For example, they are really fast. And so that's fast, no human can always be. And there's also a history of humans that also not a robot will not have this history. And so he will not fully understand humans ever, I think. There is also a discrepancy. That means when something gets nearer, that does not mean that that means also that the difference becomes also greater. And so from the intelligence standpoint, there are some parts, for example, they are slightly fulfilled. For example, when you look at machine learning, this is quite far away from how humans are operating. There are existing better theories now in the field, but they are just in the beginning. And so it's also the beginning how to use them. For example, in autonomous vehicles, they should have to use these new technologies, but they are still emerging. And so they have to need, for example, more feedback loops. And what is totally lacking is what is, for example, ethics, and what is, for example, this creativity. So it's very difficult to compare this. And so, I think it's really not understood what, for example, what is emotion and creativity, for example. And this is, we begin first to understand it, but in my opinion, it is solvable. It's a kind of calculation solution which you can calculate with numbers, but maybe we don't have the theories now. Our theories are too primitive now. So but we could use also, and I think it's a quite important thing that we have a co-evolution. At the moment, I think a robot or intelligence is in the very beginning, so to speak. This is like a very young child, so to speak, maybe not born even. So this is the status quo of the intelligence. I don't think that we have already built so intelligent machines, but we can build more intelligent machines. And if we would have, we would not have such a big problem with sustainability. And so we have to solve this problem of sustainability together with computers and robots. And so this is very important. And for example, also for the traffic, that means it would be much more wisely to have much more such video conferences and much less traffic, for example. It's much more productive, I think, but it's very difficult to communicate this and also to do it yourself. It's equally also difficult.
Thank you. Well, yes, thank you, the head. Yeah.
Thank you, Bernard, for your presentation. Obviously, thank you for your answer to everyone's questions. If anyone else in the participants has any more questions for Bernard, please use the chat function to ask him that. So I'm just going to share my screen to move on to the next presenter. So hopefully everyone can see that. So again, so returning, we have Tajim Mohammed Niamatullah Akund from the University of Business and Technology in Bangladesh. And the second paper he will be talking about is IoT security perspectives and probable solutions. Thank you.
But the affiliation of my name is wrong here. I am from Daffodil International University. I don't know why it is written Bangladesh University of Business and Technology.
Apologies for that. That's a problem on our behalf. Apologies.
Okay. So thank you for giving me the opportunity. I am sharing. Okay, I think my screen is visible.
Yes.
Okay. So this is my second paper of this conference, which title is IoT Security Perspectives and Probable Solutions, where we have suggested some security perspective solutions. And these are the authors. And nowadays, the Internet of Things is a buzzword. And in this paper, we have analyzed some Internet of Things systems. We found various vulnerabilities and security faults in some systems. We found various previous works and models to solve the security issues, but those are not enough. This paper has an aim to establish a new model that may be applied to IoT system to acquire more security. Finally, we have proposed a model to secure IoT systems. We have analyzed that model from various perspectives and found that it may be a solution to the security threats of IoT. So the objective is to find the security perspectives of IoT-based systems and suggest a secure way for IoT-based systems. Why we need this? Because we can measure our medical data or several confidential data with IoT systems and send those data to our doctors and friends and to some other databases which are very confidential. We don't want to share that data to other persons. We may monitor our home with IoT systems, which data are also private property. We may make automated systems to control our business and home with IoT. If anyone get access to them, it may cause a big problem. IoT based, most of the systems are microcontroller based and hardware oriented, where we cannot apply very high level security algorithms. We need to make small and effective solutions. Most of the IoT systems don't use any security or encryption methods, most likely. some IoT devices may fail to fulfill data integrity, authentication, and privacy property also. So we need this. Here is a example of a e-health monitoring system. Anyone can monitor his health condition with this system. Here is several sensors like pulse oximeter, pulse sensor, and accelerometer gyroscope, by which we can sense his or her pulse and monitor what is the condition of his body, and send those data to IoT platform. And from a different place or from a distance place, a doctor or the patient's friend can monitor his health condition without affecting him with some virus. Like if a corona patient is using this device, we can monitor him from a distance place without affecting me. So this type of systems are nowadays we are developing, and if the data is not remain private, then may cause some problem. And if we don't want to share the data to other peoples, then it may cause problem. So we need a security system so that our no one can know our private data from IoT devices also. For this, we have think some solution, like when IoT devices are collecting data, we can we generally generate some plain text data and send those data to cloud server or cloud database, from where other people can monitor them. So if we make some encryption with this, like we may apply several easy encryption method like additive cipher or DES algorithm also. We have think here about two type of ciphertext. Like at first we will make our data encrypted with our private key, and then we will send the data, send the ciphertext data to cloud server, from where in server our data will be encrypted with this algorithm, and second ciphertext will be generated, and that data will be available in internet and cloud database, in public database, from where anyone can see, but they cannot see the exact data. Then that our doctor or caregiver will get those data, and he will decrypt, and only the person will know our private key to whom we want to share our data. Then he will make the decryption and get the data. By this simple method, we can make our confidential data sent. And here is the algorithm we have think about. The DES algorithm is already available, and we are using this. We can also use AES and other algorithms, but that are not efficient for very small IoT systems. That's why we have used this algorithm. And the normal ciphertext system and additive cipher system is our in our first algorithm, and second algorithm is our DES algorithm. So by this system, we can ensure the confidentiality of users' data and non-repudiation, authorization, authentication, integrity, availability, and trust through this system with our proposed model. So we have think here about two layered encryption. At first, we will make a private key, and with that private key, we will make a multiplicative cipher or additive cipher, which one is very easy, and we can easily apply it on any small microcontroller like Arduino, Raspberry Pi, and other low-cost devices. We don't need here a very complex computation. So that data will be transferred to our cloud server, and cloud server will make another encryption, which one is this algorithm, and it will make second layer of encryption. And if the security level is 2 level, then our system will be more secure. And we have found that in several papers and in our literature review that this algorithm is more efficient than AES algorithm for small types of data and like IoT based data. So that's why we have proposed the system with this algorithm, but we have some limitations because we have just proposed the system, but we did not check in real-time environment effectively, and we did not apply it in field. We have just make a plan to make this, and we have proposed this model for IoT devices. We just applied in first level cipher, and this one worked nicely. And in our future plan, we are going to apply these systems with several IoT devices and analyze them. So that's all. It's my presentation. Thank you.
Yes, I have one. Sorry, I have one question.
Yes.
Anyhow, thank you for your presentation for the security and IoT. Do you create new security algorithm, or you use current algorithms?
We are using here Desh algorithm, which is already available, and we are using multiplicative and additive cipher, which one is also available, but we are applying these algorithms in 2 different layers with synchronously. That's why it makes some difference.
So as I see your last presentation, its limitation, you're not yet doing experiment on in the real time or live environments. So any scale of experiment you did in lab or mini scale or to check the performance of your security?
In this paper, we did not make a practical experiment till now. We are working on that. We just propose this model.
I see. Okay. Yes, I have experience because the very challenges on the real time or live experiment later on, because many attacks from our side on the security on data, because in the real internet scenario, many attacks, and hope your algorithm can be performance well and can solve any other. Yes, you can continue. I think you can continue to the next step is testing on the real time or real scenario on the experiment, so we can see the performance of our proposed security. So how is the performance? Is it 100%, 90% to save our data, because the proposed for the medicals is very privacy data. Thank you for your presentation. Thank you, Nahid.
Thank you very
Tajim,
much.
thank you, Tajim, for your presentation. That was very interesting, and thank you for your answers to Evzal's questions as well. And if anyone else has questions, please use the chat function to do so. I think that was our last presenter. So I sincerely want to thank all of our authors for their excellent presentation and contribution in this session, and all of our participants for being a part of this international conference. I hope this session was very informative, and all the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have been forwarded to the Springer. The publication will be live within 5 to 6 months. Kindly cooperate with the team of WS4 2021. So I'm just going to share my screen very quickly. So I think there we go. So I'd like to also thank our session chair, Evizal, for chairing the session. So this certificate is a token of our appreciation to the chair on behalf of the team at WS4 2021 and Global Knowledge Research Foundation. So thank you for your valuable presence, sir, madam. I think if I can kindly request everyone to turn on their camera for a quick snapshot of the virtual conference.
Yes. Everyone, please start the camera just for the memory. We will share this group photograph with everyone. And again, as the last time, we thank you again, Dr. Avisal, for supporting us this time as well, and hope to see you in person in London next time.
Thank you. Thank you.
Yes, we will wait for just one more minute if everyone starts their camera just for one digital photograph. Okay, nice.
Okay, that's perfect. So stay safe and take care. And precaution is better than cure. We can get through this together. Take care.
Thank you, everyone.
Thank
Bye-bye.
you. Thank you.